Okay, I wanted to talk about biohazards in the environment, and I think I have about 20 slides on this, and so this will be a reasonably fast talk. We covered the Category A CDC agents the other day, and that got into some of the viruses and bacteria that the CDC think are of concern. And those are really the high-threat agents. There's a lot of biological hazards out in the work environment that you need to be somewhat aware of. And when you're dealing with biological agents, there are different areas of concern than with things like chemical agents. And that's because these things really have the ability to replicate and thrive in other living organisms. A chemical exposure is a chemical exposure. Biological exposure is a very different type of beast. And some of the things that are on here are all going to play a role in how much of a problem a biological agent is going to be when a person is exposed to it. And a lot of that's going to depend on the biological agents itself. Some of these biological agents are extremely lethal. Some of them are highly communicable. Those Category A agents that were discussed in class the other day fit that criteria. So those are going to be characteristics of the agent itself. Then you have the environment. You've got different types of environmental conditions that may play a role in how well a biological agent can be spread. You can see it in the in patterns of cold versus hot. Many people get the common cold in the wintertime versus the summertime because of environmental conditions. And if you use the common cold as an example, we're all different. And if we could have a common cold germ on that door handle and every one of us touched it and got an equal dose, not all of us are going to get sick. Some of us are going to get sick and some of us aren't. And that's because there are tremendous variations in host susceptibility to any type of a biological response. And that's going to be dependent upon many factors. Your immunological status, your stress level is going to vary, which makes you more susceptible one day than another. So you have this real complicated interaction between the biological agent, the environment, and the host that's very different than what you see with chemical agents and some of the other things that we've talked about. So it's really, in many ways, a more fascinating field than how biological agents are spread than chemical agents. Now, the other part is there are ways to beat these that you can't do with some other types of exposures. Because in order to get sick or infected from a biological agent, you have to get the pathogenic agent from wherever it is to the susceptible host. And if you break this chain, any link along the way, you can stop the infection from occurring. So one thing you could do is kill the pathogen itself. And so if you can wipe out the pathogen, it's never going to have access to the susceptible host. And I'll use an example of this, of Legionella disease. We had a Ford Motor Company here a couple of weeks ago. About 7 or 8 years ago, in one of the Ford Motor Company plants in central Ohio, they had 4 people who got sick with Legionella disease, 2 of which died. And they have never been able to identify where the exposure actually occurred. So it's something that can happen still in a lot of different industrial environments. But if you do have the potential for Legionella occurring, it's usually going to be in standing water, water towers, air conditioning units, things like that, where water can pool and perhaps be dispersed somehow, and the bacteria will have a chance to grow. So if you're dealing with Legionella disease and you want to make sure that nobody has a problem, what you would do, first of all, is make sure that any standing water, the pathogen has no chance of growing in. So you go around and put bleach in any pans under air conditioning units and areas where water accumulates that the bacteria might grow. So you could kill the pathogen itself. That's one approach. Alternatively, you could make sure that the pathogen does not, the reservoir doesn't exist by making sure there's no water, or it can't escape from the reservoir. So if you do have areas where water is going to be present and there may be some spraying that exists, you could make sure that it doesn't escape from the environment by putting up some kind of a barrier between where that water exists and the susceptible host, so that there's no possibility that the pathogen can escape from the environment. You could also make sure that the host is not going to be exposed to the pathogenic bacteria by personal protective equipment. If you think there's the potential for exposure, you would make sure that people that go in that area have the portals of entry blocked, some kind of respiratory protection, so that the pathogenic bacteria cannot get inside of them. If that doesn't work, there are things you can do to the susceptible host. In some cases, you can immunize them to make sure that whatever bacteria exposure, viral exposure they have some protection against through immunization. And this will happen a lot if you know that you're going into a foreign country where certain types of pathogenic diseases are endemic. You can do gamma globulin shots or things like that to boost your immunity against these specific types of agents. So there's a lot of things you can do to break the chain of infection, all of which will be effective if this is done to make sure that the susceptible host does not become infected. Now, for the classification of occupational biohazards, there's anything that has potential, a living thing can be a potential biohazard. And I've got classifications here of plants and animals. You can have biohazards in that group, microorganism or the infectious agents, and plant and animal products. And just for an example of something like this, plants and animals, you can have a lot of things that are allergenic. So many types of plants cause allergies. We talked about poison ivy earlier in the semester with the skin toxicities. Things that you can inhale that may cause asthma, and there's many plant materials that can do that. You can have things that are directly harmful, different types of plants or animals. The Kentucky Safety and Health Network has a conference every year up in Louisville, and many of you are probably going to be attending that next spring. And about 2-3 years ago, one of the topics that they had was on snakes, because a lot of people working in construction areas are going to be exposed to snakes. They can disturb snakes, and there are several poisonous snakes in many parts of the world. And if you get bit by a snake, that can be very, very problematic. And they thought this was something that people in safety needed to be trained about a little bit. So you can have you can have things that are directly harmful, like a snake. It's one of the reasons I live in town, by the way, rather than out in the county like I used to. I had a koi pond, which was really beautiful. I really took a lot of pride in raising my koi. They were beautiful fish, and it was a lot of fun. And my dogs would hang around the koi pond and try to catch frogs, and it was a lot of fun until the day the water moccasin came. And one of the things that you have to do at the koi pond for maintenance is twice a week I'd have to clean out the filters, and so to make it pretty, you don't want all these wires. So I had the outlets and wires buried under a rock. And just a strange day. I had just got my new Weimaraner, and I was training him to get his CGC certificate. As I took him away and let the other two dogs outside, and they were barking like crazy. The next thing on my to-do list was to go outside and change the koi pond filters. So the dogs are out there barking like crazy, but they're dogs. They always bark like crazy, so it was no big deal. And I finished training the one dog, and I went outside to do the filter, and that rock that sat upon the outlet was moved. And my one dog was standing there with his foot like this, and the other dog had blood on its head. And I looked down, and there's this snake, with its mouth wide open and as wide as it can be, just looking at me. And I thought, that looks like a cottonmouth. So I went inside and Googled on the internet cottonmouth, and there's a picture of a cottonmouth. And I said, oh, that's a cottonmouth outside. So I got my 12-gauge shotgun and loaded it up. And then I thought, that's a cottonmouth. So I got my Beretta and put in a 15-round clip, and went outside, and the cottonmouth is gone. And I'm looking all over the place because there's this cottonmouth somewhere around my koi pond. And I got two dogs that have just been bitten by it, and I didn't know what to do. I called my vet. They came to the house, dosed them up with stuff.
Yeah. Shoot first, Google later.
I kind of like snakes. I wasn't sure if it was a poisonous one. I like to keep the good ones alive.
So really, just run her up.
They don't wear boxing gloves and fight off the non.
So anyway, about a week later, I'm out mowing the lawn, and I knew that snake was around there. I'd put off mowing the lawn because between the koi pond and the woods was a lawn patch, and I knew my dogs don't like snakes, so they had a fight with the snake. The snake was hurt. They killed a lot of snakes, and I had a hurt water moccasin somewhere in that area. So I was mowing the lawn, so I had to go mow the lawn. I did it this way, in a circle fashion in that area. Just kind of go like this while I'm mowing the lawn, looking around for the snake. And I get to the edge of the wood line, and there it is. It's like 3 foot away, just kind of coiled up. And I thought, I got you now. So then I went back in the house and got all the equipment that I needed there. I got the Beretta loaded up. I got the 12 gauge, and some people say you can use a shovel or something like that. I didn't want to do that. By the way, just as an aside from this, I had called Dr. Zimmerer over at the biology after this snake had happened, and event had happened, and said I had a snake loose. I don't know where it was, and he never called me back. While I'm outside with the shotgun and the Beretta, he actually called back and left a message on my machine that said, "Don't kill the snake. I'll come out and help you." Too late. I found it. I shot it with the shotgun from a distance, and the shotgun forcefully took it into the woods where there was very, very high grass, and I could see something in the woods flopping back and forth. And then I had a problem with, I got a wounded snake there, and I don't know if it's dead or not, and I'm not sure exactly where it is in the tall weeds. And then I thought, my dog Maverick hates snakes, and he's mad at this snake for biting him in the head. When they get bit by water moccasins, his head swelled double its size. It was lucky that both of them lived. They pulled through. I thought Maverick has a real grudge against this snake, so I just went in the house and got Maverick and said, "Maverick, go find that snake." 5 seconds later, he brought the snake to me, and I took it up to Zimmer, and it definitely was a water moccasin, and he was a little upset with me for killing it. But I said, look, I called you, and you waited a week. If you'd have been a couple minutes earlier, you could have saved it. And anyway, after that, my wife insisted we move, because this koi pond was right outside of our bedroom porch, and she just never wanted to live in a place where she could sit on her porch and know the water moccasin was a couple feet away. She doesn't like snakes. I don't quite get it, but anyway, snakes are directly harmful, and they can be problematic. And then there's vectors. That was another problem with living out in the woods, is that you can get a lot of diseases from vectors like ticks, and we'll talk about those a little bit later. But I had a good friend who is an avid outdoorsman, actually taught a course on occupational biohazards and knows his subject quite well. And he's not afraid of water moccasins, or we have actually 4 poisonous snakes around here in Kentucky. Not worried about any of them. He's from Arkansas, and there's even more down there. Totally unconcerned about snakes, but ticks scare him to death because of what he knows about tick-borne illnesses. And he's not worried about Rocky Mountain spotted fever, Lyme disease, some of the more common ones. But you can get a lot of very serious diseases from ticks. And he considers the tick the scariest creature out in the woods. And that's a vector that can be really problematic. Then you have the infectious agents, and we've talked about the infectious agents from the bacterial, viral, rickettsial, the chlamydial families, and we'll get into a couple of those on some other slides, but the main areas are the viruses and the bacteria. And some things like the viruses that were talked about in the category A agents is your viral hemorrhagic fevers, your hepatitis viruses can be problematic. In terms of your bacteria, the things that were talked about in the movie, the tularemia, but also other things like tuberculosis fit the bacteria mold as well. And then you have plant and animal products. And if you are working in areas where laboratory research is going on and they have animals like rats or pigeons, a lot of people can develop allergic reactions to those exposures. If you're working for agricultural companies, ConAgra, Cargill, etc., where you have a lot of organic dust exposures, you can get people that have exposures to plant and animal products and can develop allergic conditions. And some of them can be quite serious if they become asthmatic type reactions. So there are a lot of different things that fit those areas. Now, the one area I wanted to focus on a little bit more are some of the infectious agents and associated diseases. From the bacteria side, I already mentioned a little bit about Legionella and the outbreak at Ford. But this was a bacteria that grows in water systems. It got its name from an American Legion convention in Philadelphia back in the 1970s. It had been around for a long time. It was known as Pontiac fever at one time for an outbreak in Detroit around people using a hot springs area. But it's just a bacteria that grows in water supplies, and when it becomes airborne, usually from splashing, or in the case of Legionella disease in Philadelphia, it got into the air conditioning system, and so you would have the spread of the bacteria by inhalation, and it has a reasonably high case fatality rate. Several people who were exposed died at Legionella. At Ford, it was a 50% case fatality. 4 people were exposed, 2 of them died, so it can be a very, very dangerous type of a microorganism. Tuberculosis is another bacterial agent, and tuberculosis is one that was on the downslope of the United States for a number of years. People with active TB were becoming more and more rare, unless you like to watch old westerns where you saw a Tombstone, for example, where you saw a full-blown person with tuberculosis and kind of end stages. you don't really have much experience with what happened to people with tuberculosis and how common it was at one point. But the U.S. has made tremendous strides in eliminating tuberculosis until the late 1980s. And then for the first time, we started to see a resurgence of tuberculosis in the U.S. And a lot of that was from many different factors, including a higher population of individuals who were immunocompromised in some way. And this started more of an effort on NIOSH and OSHA to try to minimize spread of tuberculosis. And OSHA was actually very close to making a standard on tuberculosis. And one of the first things they did was ask NIOSH, okay, we're thinking about making a standard. What would you recommend be the components of the standard? And NIOSH wrote a recommendation on tuberculosis. And it was serious because there was about this time period, there was a case in Bath, Maine, where a shipyard worker who had active TB infected 400 of his coworkers. And that doesn't mean you're going to get active TB. There's a lot of components with it, but there'll be a positive test that shows you've been exposed to tuberculosis and infected by it. And so this was becoming a real major concern in the U.S. about tuberculosis. So what NIOSH did was look at it and ask a question: how many tuberculosis bacteria could it take to potentially infect someone? Anybody know? One tuberculosis bacteria could potentially infect someone. So NIOSH wrote a recommendation that if there is any chance or possibility of exposure in a workplace to tuberculosis, people need to wear level A suits. And they wrote this up in the recommendation. So this is hospitals, prisons, a lot of different areas where, especially hospitals, they recommended that anybody who was in contact with a potential tuberculosis patient wear a level A suit. Now, I used to work in a teaching hospital at the University of Arkansas for Medical Sciences. We had to do TB skin tests every year. People who had no patient contact, every year would come up with a positive TB skin test, because what would happen is you'd leave your office, you'd go down to the cafeteria for a cup of coffee, and you have no idea who you're going to run into in the hallways or in the elevators or anything else. You could have all kinds of people with active TB coughing, and all it takes is just the inhalation of one tuberculosis to potentially infect you. So it's very problematic to try to set up a TB program like that. And when the medical community heard that NIOSH was recommending and OSHA was probably going to set up a standard that required anybody in the medical community with potential contact with a TB patient, which basically is everybody in the medical community, especially in the ER, etc., wear a level A suit, they went absolutely ballistic, absolutely crazy, because they said, patient care is part of what we do. We've had many, many years of dealing with infectious agents. We recognize there's an element of risk associated with dealing with sick people. We're willing to take it. We don't think it would be good for patient care if a patient came to us and they said, wait just a second, went in, put on a level A suit, and came back and said, I'll see you now. That's not going to be something that the patient would find comforting. And so the medical community would absolutely nuts. And nowadays, we have sort of a compromise between what OSHA and NIOSH originally wanted to do and what medical community will do. They'll wear an N95 respirator. I'm not going to get into respirators this semester, but it kind of looks like a duck mask that is recommended when you're in contact with patients who are likely to have active tuberculosis. But it is a problem and a risk factor with the medical community. And in fact, I mentioned this morning I was emailing a couple of my friends about the Bon Jovi's daughter and from our Dunham. One of those friends of mine is a pulmonary physician, and he actually got TB during his residency. He did a residency. He's a New York City kid. And he did his residency in the Bronx for pulmonary medicine and was working with TB patients and actually got tuberculosis and had to be quarantined for a specific amount of time. So it's something that does happen to people even today when they're working with these patients. And then the last bacteria that I wanted to kind of mention a little bit more is anthrax, because that's a category A bacteria. And as I talked about in class the other day, that can be responsible for not one but three different diseases. You've got the cutaneous anthrax, which can cause scarring and pitting on the fingers or areas of the skin that comes in contact with it. You've got GI anthrosis, which causes a scarring and pitting of the GI tract if you eat contaminated materials with anthrax. And the most serious disease is the respiratory anthrax. And usually that means the spores need to be weaponized before you can get them into the 1 to 5 micron size to cause that disease. And that can be a life-threatening disease. Now the next class is the rickettsial and chlamydial agents, and things like Q fever and Rocky Mountain spotted fever, which is a tick-borne disease, can fit into this. Q fever is an agricultural disease that gives flu-like symptoms. It's one of those bizarre type diseases. If you ever take the CIH exam, and one of my former students took it 2 weeks ago and passed it, really proud of him. Got to know all this little trivia. And the Q fever was on my CIH test. They talk about that a little bit, that it's a disease in agriculture that's associated with a febrile illness. And then the last bit is some of the viruses. And I wanted to spend a couple of minutes. I've got some extra slides on a few of these. But I have rabies, hantavirus, HIV, and hepatitis. The bloodborne pathogen standard that came about in the late 1980s was designed primarily for the bottom two, hepatitis B in particular, and also HIV to a less important extent. But hepatitis B was a real problem in terms of transmission in healthcare workers, and OSHA felt that a standard was required that incorporated a lot of elements that are very protective of bloodborne pathogens, and HIV falls under that, but again, it was primarily for hepatitis. And then a couple of the other ones are the hantavirus and the rabies, and I've got a few slides I want to talk about on hantavirus because some of you may be dealing with this, but I also wanted to mention rabies as well. Rabies is, I think, one that's a little bit interesting in many ways. You think you're getting rabies if walk outside, there's a mad raccoon that comes up and bites you on the ankle, or a bat swoops down and bites you on the hair. You think of getting rabies from those type of exposures. When I first moved to Kentucky, I was reading the Morbidity and Mortality Weekly Reports, and they had a report out of Cumberland County, Kentucky, about a woman who had died of rabies and had no history of exposure with any rabid animal. And it was really kind of an interesting article, and the editorial documented at least 24 other cases of people who had been diagnosed with rabies. And if you're diagnosed with rabies and you get symptomatic, the case fatality rate for rabies is the highest of any disease. It's 100%. You get symptomatic, you die. There's nothing you can do about it unless you're treated before symptoms occur. Once symptoms occur, it's over. And usually people that are treated with it are treated because they have some knowledge that I was bit by this animal or that animal. If a person presents with symptoms and no previous contact, there's really nothing that can do. That can be done. It's 100% case fatality rate. And the reason that this was an important article is this person was doing some construction in their house from remodeling, and there was potentially some bats that lived in an area, and they disturbed the rat guano. And this particular article that the CDC published in Morbidity and Mortality Weekly Reports postulated that rabies could be spread by airborne transmission. And they had several dozen cases to back it up that this is a potential route of administration. And that's kind of scary. So if you're doing remodeling or working in areas where there's bat guano and you disturb it, you might want to wear respiratory protection because it has been thought that it can be spread by inhalation other than just getting bitten like had been thought. And hantavirus, which I will talk about in a few minutes, is very similar to rabies in many ways, but it can be spread by airborne aerosolization. So you breathe in hantavirus, you can get this virus, and it's very serious as well. Its case fatality rate's about 30%, which is real high, but not as high as rabies. But I'll go into a couple of these in a little bit more detail, some specific examples. The first is on ticks, and the American dog tick lives over in the areas where it's yellow, which we're living in now, and Arkansas is over here in this yellow area as well. Just an interesting sideline. I'm going to mention Rocky Mountain spotted fever and a little bit about tick-borne diseases. I lived out in the Rocky Mountains for 10 years. I was outdoors almost every weekend doing something. It was mountain biking, kayaking, cross-country skiing, hiking, whatever. I really liked living in the Rockies and enjoyed the outdoor life out there. I never saw a tick. The whole years I was out there, I never saw a single tick in the Rockies. Not one. I moved to Arkansas, and I can say the same about Kentucky. I go to the woods at all in the summertime. I come back covered with ticks. My dogs are covered with ticks. I've just never seen a tick population like in this part of the world. But in the Rocky Mountains, where Rocky Mountain spotted fever is supposed to come from, I never saw a tick the entire time that I lived out there. But here, ticks are all over the place. I treat my dogs with Frontline, and we lived out in the woods. I felt that Frontline was just a tick delivery system, because if you gave them Frontline, what would happen is the ticks would jump on the dogs and they'd say, I'm not going to bite this dog. It's got Frontline in it. I'll die. I'll just hang out on the dog till it comes in the house and jump on the sofa and bite Dr. Keller. And so that's what they would tend to do. when we lived out in an area where there was a lot of ticks. But ticks can cause many types of diseases, and one of which is Rocky Mountain spotted fever. And again, it's named for Rocky Mountains, but I never saw a tick all the years I lived in the Rocky Mountains. But it's most common Rocky Mountain spotted fever. Most common state you'll get this is Arkansas. That's the number one, and Kentucky's not too far behind. So out here in the South is where you'll find most cases of this particular disease. Not in the Rocky Mountains. It is one that's endemic in this area. And it causes a skin type disorder, and it can be fatal if case fatality rate's not that high, but it can be a very serious illness, and is spread by ticks. Lyme disease is also another one that you can find endemic in this area that is can be problematic. But around here, the most common disease from ticks is STARI, Southern Tick-Associated Rash Illness, which isn't pleasant. You're going to have a welt for about 6 to 8 weeks from where the tick bites you, but it doesn't tend to have any systemic toxicities associated with it like Lyme disease or Rocky Mountain spotted fever potentially could. The next is hantavirus, and hantavirus causes a pulmonary syndrome, and it's spread by mouse droppings. And so this little picture of a mouse, and if you get into areas of the American West in particular, there are cases of hantavirus that occur, and I just have a couple of slides from past decades or so with about 500 cases, many of which died, some of which survived it from hantavirus on a seasonal type of a graph. And a lot of these occurred in an area of the United States called the Four Corners, and I have two things up on the top, Four Corners versus non-Four Corners. And of these cases that were affected, the case fatality rate down here was 35%. So you had of the all people who were exposed to hantavirus, about a third of them died. So it's a pretty serious illness if people get it. And as you can see, there's a distribution among people who got hantavirus. Well, I wanted to talk about it a little bit, mainly off of this map on where hantavirus is, because I've had several students that have gone to some of these states with high numbers, and part of their safety plan is a rodent control program to try to make sure that hantavirus exposure doesn't occur. And if you look out here in the west, you have this area called the Four Corners. Anybody ever been there? It's one of these incredibly stupid things you do. I was on a road trip with my friends one time, and we were driving down from northern Utah to somewhere in Arizona or New Mexico. I can't remember exactly where we were going at the time, but you drive along on the interstate, and then there'll be a sign that says Four Corners, 30 miles away. So you drive 30 miles through the desert, and it's desert, there's nothing there, and you get to a certain part of the desert, and then there'll be some tents set up where people will sell you jewelry and stuff like that, in a restroom, and a big seal out in the middle of the desert that says Utah, Colorado, Arizona, New Mexico. And so you go out there and you put a foot in Arizona and a foot in New Mexico and a hand in Utah, hand in Colorado, and your friends take your picture, you get back in your car and you drive another hour back to the interstate and head on your merry way. It's really stupid to do, but if you're in that area, you just have to go do it. I got to be in 4 states at once. Anyway, there was an outbreak of hantavirus in the late 1990s in that particular area. And what was kind of unique about it is that some of the first cases were extremely healthy young adults, Native Americans, in fact. One was an 18-year-old track star who was an extremely gifted athlete, died of hantavirus. And that's unusual. Usually when people get respiratory diseases, the people who die from it are going to be the very young, people who have pre-existing conditions, and or people who are elderly. It's usually not healthy young people who will succumb to hantavirus. And yet it happened out there, and then there was an outbreak amongst one of the Native American villages where several people died, and they really weren't sure what was going on. This actually caused the Center for Disease Control to come out with the team, just like the Dustin Hoffman team in Outbreak, to try to determine what was occurring. And they had no idea. They could not figure out what was occurring in this particular outbreak. So they talked to the Native Americans, and some of the people who were the elders of the tribes were telling them that their tribes had a history of this kind of disease affecting their people. And it happened in years where the rains were great, and this tree had had a lot of nuts produced, and that gave the CDC people some indication that it may be fluctuating due to a food abundance and that would lead to a higher rodent population, and that led them to believe that it could be affected to rodent droppings. But it was a case of interacting the scientists with the Native Americans. This has been written up in several sources. It's really a fascinating story on how this was discovered. And it was found to be hantavirus that was out in the native West, and this was the first time that it was known that this particular disease existed. Now, it wasn't the first time that the U.S. had ever heard of hantavirus, which is an interesting sideline for the story. Back in the Korean War in the 1950s, we had a lot of American soldiers die of hantavirus because in Korea, hantavirus was also endemic within the pig population, and it caused a kidney disease, not from the mouse population causing a respiratory disease. Now, this became kind of problematic when hantavirus was discovered because out here in Utah, we have one of the facilities I was talking to you about the other day. I mentioned Fort Detrick, I mentioned Plum Island, I mentioned Pine Bluff, Arkansas, and the Dugway Proving Grounds. And the Dugway Proving Grounds was involved in developing and testing biological warfare agents. So there became a real concern among people living out in that area that the United States Army had taken hantavirus from Korea, brought it to a laboratory in Utah, bioengineered it so that it could be transmitted through mice. The mice got loose in the desert and was causing this particular problem. Serious concern at that time. So serious, in fact, that the magazine Scientific American actually had an article devoted to genetically tracing back Korean hantavirus versus a hantavirus found in the American West to determine whether or not it had been biologically engineered, and found out that it had not been, that it was actually endemic in that area for a long time. So it is a problem out in the West. If you've read the papers over the summer, people that were camping in Yosemite and living in a cabin where mice had been in, which is about every cabin that you're going to find in the West, and we want to clean it up by sweeping it out. Once you disturb those mice droppings and this stuff aerosolizes, you can breathe it in. It can cause a respiratory disease. And again, it kills about a third of the people that breathe this in. So it can be a real serious problem. And if you work out in the West, in these areas that have high numbers, a rodent control program is part of a safety program, and it's an important component due to the very serious nature of this particular illness. The last time I was in Utah, a couple of years ago, there was a fatality from hantavirus in Cache Valley, which is where Logan is that I was visiting. It was in the local paper, so it's not going away, and it's a problem out there with this particular disease. Any questions on hantavirus? I just want to make a movie plug. I was just talking about a Native American track star. If you really like sports movies, one of the older ones that was made, which is an absolutely great sports movie, is called Running Brave. Robbie Benson starred in it. It's a movie about Billy Mills. Anybody ever hear of Billy Mills?
The one he was a Native American, went to college, like professional ball, went to the Olympics, or summer league ball, and got all these medals stripped away or something like that. Is the same person?
No.
Okay, never mind.
You're thinking of Jim, the Syracuse guy, Davis. What's his name? That'll come to me in a minute. The cross player that went and got the medal stripped away for that. But he was a Syracuse University player. I don't know who you're talking about. But Billy Mills kind of followed the same path. He went to the University of Kansas as a track star, dominated in the NCAAs. And the movie basically talks about some of the transitional problems he had being a Native American, trying to fit into Kansas. It didn't work. After a couple of years, he basically told his coach off and quit. And then joined the Marines and decided to start training again because he really, really liked running. And then he decided to go out for the Olympics and made it as the alternate on the Olympic team. And one of the main guys got hurt, so he was able to compete in the 1964 Tokyo Olympics. And to this day, he's the only American to ever win a gold medal in the 10-kilometer run. That's the only time it's ever happened. And the movie's really fascinating. You can Google Billy Mills YouTube 10K and watch the race. It's an amazing race because he almost gets knocked down in the last lap and comes up and does a phenomenal speed. But if any of you have ever run 5Ks or 10Ks, you kind of get obsessed with the times. Like my best time ever in a 5K is 17:43. And I've decided I was going to beat it the next year, and I trained like crazy. Came out and did a 17:43 again. I just could not beat that time. But when you train a lot, it's incremental measurement gains that you make. It's usually just a second or two or 5 or 10 seconds that you will get once you get to a certain level. And if you're a track star and you're on the Olympic team, you're not going to make great strides in your PR during a race. He beat his PR by close to 2 minutes in this race in the 10K. Unheard of. I mean, it was just a superhuman effort, and the movie is really good. And I had an opportunity to hear him speak a few years ago. He's a pretty remarkable individual, and he came from that environment of the Four Corners. But anyway, that's my plug for a good sports movie, Running Brave, with the life story of Billy Mills. And it was fun meeting him. I've met, I think, 3 or 4 gold medalists in my life, and it's always been an honor every time, and he's one that was a huge honor to have an opportunity to meet. Now, for other occupational biohazards, we have some fungi, which are things like histoplasmosis, farmer's lung mold, and spirotrichosis. I showed you spirotrichosis earlier, and spirotrichosis was with the Rose people who had the swelling up of things on their arms. Histoplasmosis is endemic in the Ohio Valley. When the flocks of blackbirds come flying over and leave droppings, one of the things that can occur is histoplasmosis. And then there are parasites that can be out there as well, things like Giardia lambda, which is a protozoa, or amoebas, and there are reasons that you boil water before when it's potentially contaminated. And I just have a couple more slides here because I've gone too long on just going off on tangents that I didn't need to, and I need to go through that one problem. But a couple things I wanted to point out is there have been studies done to try to determine how infectious certain agents are. And I have a list here of things like Q fever, tularemia, which was talked about the other day. 3 bacteria of tularemia are enough to infect a person. Or, 10 are enough to infect a person. You get down here to some of the food poisonings like Shigella, it's going to be 10 to the 9th, so it has to be a large population of bacteria before a person will get sick. I also wanted to point out something up here. Volunteers. Infectious dose for 20 to 50% of volunteers. There are a lot of tables like that were generated in the old days where people would actually volunteer for studies like this. Hey, you want to inhale some tularemia or Q fever or inject you with some syphilis to see how much it takes you to get sick? And these were actually done on populations of people, and they were primarily done on prison populations and on American servicemen. And this is something that we're not proud of at all. But a lot of these tables that you see from historical on where we got some data on how infective these agents are were done on a population of people that were, quote, volunteers, but in reality they weren't volunteers. They were fortunately we have processes and procedures in place that this kind of thing doesn't happen anymore. But it did happen years ago. But it does give you an indication of some variation of what can happen with different doses of these agents. And basically anybody who's exposed to an occupational biohazard in any industry can have a problem. And I just have a laundry list of things here. And just a few slides here that you can read on your own for things to do for HIV, precautions that need to be taken, for hepatitis, precautions that need to be taken. Tuberculosis is also an area that precautions need to be taken, and the bloodborne pathogen standard does cover those areas. And I think I'll just skip that material because I did want to spend some time going through the